Yes, so my name is James. I'm part of a company called TwelveLabs. Huge thank for the Voxel team for hosting me at the NA Union AI office, of course, in Seattle. I'm sure a lot of folks here are excited about computer vision. So the talk, my focus today is going to be focused on video intelligence and specifically talking about how we can engineer context that the model can reason over. And structurally, I'll talk a couple of few things. So number one is why we cannot apply language model approach to video understanding. Number two is the four pillars of context engineering. And number three is going to be how our partnership with Voxel help unlock a lot of this context engineering workflow for video intelligence. So just a quick slide about our company. TwelveLabs is a research-driven startup building video native foundation models. We have office in APAC as well as in North America. And our core bet is that video is not a special case of text or images. You need representation that preserve time, multimodalities, and semantics, as well as infrastructure that can serve it. So the point of our focus is really we're not a wrapper around generic language model. We actually build the entire technology stack around video. So why does video matters, right? I think the context of this session, this entire meetup was around video and some of the issue that you tackle, tackling from a computer vision, but also from a foundational model perspective. So here's a high-level slide from a statistical point of view. Essentially, video is turning into one of the dominant container for knowledge, right? You got a lot of footage on, in sports, in media, social media, YouTube, etc. And this number here coming from Cisco and report estimating that video is about 82% of global IP traffic, right? So for a lot of people, right, you capture content and video from your device, different streaming, different services. So the amount of footage coming into our world today is increasingly becoming more and more popular. For computer vision practitioner, right? This basically means that you have to pay attention to video understanding. You cannot just stop at image classification, image understanding anymore, right? Because now some of the challenges here is how can we find, slide, curate, and reason across time, when you deal with video content, right? So this next slide is talking about some of the core complexity of dealing with video, right? The key mental model that I want to talk about is that video is actually a spatial temporal volume, not a sequence of frames, right? I think this is a very important distinction that I want to emphasize because traditionally we tend to use CV model to extract frame by frame, extract metadata and tags from the footage, right? But that basically means a lot of different things, right? What changed, what caused what, the causality, what happened before and after, how audio and visual all lie together in addition to text, right? So there are approaches in the past that basically do captioning with sample frames. The thing is that approach, they throw away causality, they throw away progression. And so the issue that we try to tackle here with video intelligence is actually how can we retrieve and assemble evidence over time, right? So let's quickly talk about why some of the approach on using language models struggle over here. So this slide showcases the three limitation, right, of applying language model into production when dealing with video understanding. Number one is wrong context. So language model wants token versus video is contiguous signals, right? So if you natively try to tokenize video, that you will lose a lot of structure that you care about. Wrong memory is the other bucket that I want to put over here, right? Bigger context, right? Like language model, you try to increase your context window, but when you're dealing with video, you actually search across archive of content. You're talking about multi-hour, so you actually need longer term memory that capture throughout all the decades, right? That can go deep into the memory archive from decades ago and find that scene that matters. And the last one is raw reasoning, right? So language first model naturally don't really focus on motion and temporal relationships unless you give them very highly structured evidence. So when you try to build video intelligence, you have to really take a look in details on that sort of spatial temporal understanding and motion to really understanding kind of the relationship between frames and objects moving through time, right? So retrieval and packaging, right? whatever happening on your video frames becomes super important, right? So the title of my talk is called Context Engineering because I want to reframe a lot of the problems in video understanding as context engineering. So the definition that I use for context engineering is the art and science of filling the context window with just the right information at each step. So this slide is actually an adaptation of a well-known blog post from Langchain, one of our thought leadership in terms of agentic design and like context design, right? But there are 4 key pillars associated with context engineering: write, select, compress, and isolate. And for the next few slides, I will go deeper and apply these pillars into video, right? And one thing I want to emphasize with respect to this slide is that this is not just about prompting. This is actually system design, like what gets written, what gets stored, how the information is being retrieved, and how it's being packaged. This is a pretty cool motion that talks about like TwelveLabs video intelligence stack and how we try to engineer our stack, towards that, the 4 pillars of context engineering. Essentially, there's 3 layers. We have the write and encode layer that basically, encode spatial or temporal semantics from raw video content. And then we store this representation in a spatial or temporal context store, which is purposely designed for semantic retrieval. And then we use them through API. So we offer our models via API, search, embed, and analyze, as well as agentic workflow downstream. Imagine if you comfortable with computer vision, model inferences. Now you can do everything from representation, indexing, retrieval, and reasoning all across in a single pipeline. And so you can see here on the slide there is these horses that running, right? Marengo and Pegasus, and these are actually the name about 2 foundation models. So Marengo is our multimodal encoder, multimodal video embedding model. It basically maps video, audio, text, and image into a shared representation that you can retrieve with natural language or examples. This becomes super important because now retrieval become semantic and time aware, right? Not just based on the tag or metadata that you get from the video itself. In practice, from a developer point of view, we basically expose raw embeddings right from the video that you can index. You can perform downstream tasks like embedding-based similarity search, clustering of different embeddings, data set curation, a lot of the work that computer vision practitioners have to deal with on a day-to-day basis. So it's an any-to-any retrieval. Find me that exact scene where a player throwing a ball. Find me a person appearing on a TV news footage, right? So text-to-video search, image-to-video search, audio-to-video search, all of these very powerful find needle in a haystack problem that you can perform, right? Especially across millions of archive footage. The second model that we have is called Pegasus. So this is a VLM, a video language model, that take video as input and generate text as an output. Essentially, it takes all this embedding representation from the video footage and then produce structured text output, whether it's JSON, summaries, chapters, metadata, right? So you can ask questions like, provide 5-sentence summaries of this clip. Help me provide, structured JSON output from the first 10 seconds of this video, right? So just like how you chat with your language model, now you can chat with a video, right? But it's very factual and grounded on actual information in the video itself, right? Not just making stuff up from external sources. And so what's next, right? Beyond, so we got an encoder, we got a retrieval. What our company is focused on building is actually the reasoning layer, which is the video reasoning agent. This product has not been released to the wild yet. Should be soon, in a couple months. But the idea here is, can we build a video reasoning agent that can orchestrate multi-step retrieval and reasoning over video memories, right, across both time and space, right? In terms of time, how can we reason over years of footage by focusing on doing memory first retrieval and multi-step timeline? And then in terms of space, you want to combine perspective across many cameras and many streams to build current understanding. And this is especially important for live footage, security, surveillance. When you have footage from an edge device, you have it from the TV screen, combining different angle, horizontal, vertical, right, all together. So that's what I mean by time scaling and space scaling right now. So now you got this sort of horizontal purpose video reasoning agent that can combine all the best principles around context engineering together. Yep. So that's a couple of slides just talking about TwelveLabs as a company, but I also really want to dig into the science of context engineering. And the next few slides will talk about the 4 pillars with more concrete examples. So there are 4 pillars again. So we got right context, select context, compress context, and isolate context. Each one is a very powerful level that you can measure and improve. So in terms of writing context, in the language here, it's basically how can we make video legible to AI agents, right? And there are a few things that you can do to make that happen. You can produce transcript, structured JSON output, time-coded events from the video footage, right? Which will then be put as input into your LLM's agent of choice. You can obviously create embeddings, right, that preserve the semantics knowledge, not just labels itself. So the goal here is not just about capturing everything, right? You want to create this sort of stable knowledge base that you can retrieve them repeatedly. And actually, this is the part where computer vision can come in handy because a lot of the models detection, scene boundary, segmentation already do a lot of the great work in terms of shot detection, scene tracking, right? And now, we can just extend a lot of that work into multimodal semantics, right? So after the first step of writing context, the next thing is how can we bring that into the model? So this is the second pillar, which is select context, right? Essentially, you want to perform retrieval, right? You want to do search, finding only the most relevant evidence clip, right? Not the entire video. Retrieval here, right? I think I mentioned about a Marengo model in the past, but you want to do semantic search over a long amount of video segments. You want to do that by specific natural language query. You can even do that by metadata. Tool calling, and the holy grail is you can combine both metadata and semantic search together to get a hybrid retrieval system, right? That allows you to select only the most relevant clips, and actually this is super relevant for a lot of legacy solution. Typically, those video stay in Oracle or Snowflake, Databricks, MongoDB kind of data platform, and they categorize those video based on metadata, tags, video ID. So now you want to create another row in those platform only for the embedding stuff. And now you can combine kind of the metadata and ID together with that semantics, right? To get this sort of hybrid retrieval system, for your application layer. The benefit here is with better selection, you will get less hallucination, reducing the cost because you don't, search for the entire thing, right? You only retrieve the most relevant knowledge that you care about. So that is select context. The third pillar is actually compression. So compressed context in video understanding here means how can you increasing more signal per token without losing the meaning. So I put this example here of an application my team built for security and surveillance use cases. So we look over a couple of camera footage and it's used our VLM model to provide key insights, recommendation, any alert patterns, incidents, right? So you get this very strong opinionated output from your video language model, right? And this is super important because summarizations, right? You turn a long segment into very concise synopsis. Temporal compressions here means you can. Especially for example, for camera footage, there'll be a long stretch of time when nothing happened. So you don't really want to pay attention to those stretch of time, right? You only care about the scene that matters. So temporal compression here basically means you just want to merge all the scene with similar, with high similarity score together into events, and you can ignore them, right? Modality filterings mean that maybe in certain domain you care more about audio, like music, sound. In certain other domain, you care more about the visual information, like sports, media, right, action happening. So these are, or in interview, you probably care more about the speaker and the conversation itself, not so much about their movement, right? So you can, when you do search, and you can perform what we call query filtering. So you can assign more weights into a specific modalities, so that the search result will more bias towards that specific modalities. Especially if you work with embeddings and you build your own a RAG system, it's important to have a strong equation that you can put on when you assign weights for these modalities, right? And then the last one is isolating context. So here it means you want to separate context into different steps in the workflow, so the model doesn't contaminate reasoning, right? So there are a few ways that you can isolate them, right? Based on time, based on different steps, based on the sources, right? Perhaps you have instruction to output that you only care about, and so you can like on your prompt you can break it down into like the metadata, the categories that you care about, and ask the video models to only look at information based on those classification. Temporal isolation here means focus more on specific scenes, specific chapters. Rolling summaries mean like maybe every 5 seconds give me a summary, right? So you like so in that case, like an 1 minute video, you got like maybe 12 summaries, right? 5 times 12 equals 60. So now you can combine that summaries together into like one aggregated summary, and so now you got like one single summary for the entire 1 minute long video instead of like 12, right? So those are some of the techniques that allows you to reduce the context window when you talk to a VLM. This example here on the screen is actually a slide that I got from I think a blog post from Manus, the company that got acquired by Meta, but they have a really good partnership post about how by isolating context you actually reduce the KV cache, which is the inference pipeline that they do when the agents being calling do a lot of true call, right? So it actually have a meaningful like engineering reduction in terms of footprint, how many call inference call your system will make when you design like very complex multi-step workflow. So those are the couple slides that I share in terms of like the 4 pillars of context engineering for video understanding. The next 2 slides talk about, okay, so now you treat context as infrastructure. What else can you do, right? And so one thing I want to showcase is actually this concept of short-term and long-term memory. So in video, right, short-term memory is essentially any like intermediate summary of what just happened in the current interaction. Long-term memory is essentially embeddings and indexes across entire library, right? Like let's say you're the NFL and you wanna have all the footage of all the Super Bowl game over the past 50 years. That is your long-term memory, because now you have archived all your game footage, right? You cannot like just look at like this season, right? And so you combine kind of short-term and long-term memory together. Really like the way we build our models, right? We build a multimodal encoder to tackle long-term memories, which is typically stored in some sort of vector storage that allows customer to retrieve, relevant embeddings across years and years of footage. And Pegasus is more like a short-term narrative memory, right? You get like a quick description about like this scene, this specific timestamp, like zoom in really deep into a specific object's person. So the combination of both of these like short-term and long-term memory together will allow you to do both, right? Answer very detailed question about specifically, but also like reason across the whole archive together, right? And now let's say you want to build an entire technology stack with these 2 approach. You got this context pipeline, right? Number 1 is you want to index your video, and then you write the representation with the video foundation models. Now you store all those information into some sort of, I think I mentioned this before, hybrid search, like metadata plus semantic understanding in some sort of context store. And then you perform the 4th step of context engineering, select, compress, isolate, which is available based on our API offering. And then the top one is your application layer value proposition. You actually expose your search query, your text analysis, your integration, agentic workflow, right, for customer and partners, all sort of stuff like that. And so, like just like many other foundation model company in the market, we heavily API and SDK first, meaning that developers can easily inject these capabilities into the application with API, with SDK, MCP, Cloud Code plugin, all the cool things that folks are building these days with agents, so that they can get the benefit of video intelligence directly into current engineering or technology stack that they're already building. From an infrastructure point of view, this entire process will reduce the cost, latency, and trust, right? Because now you actually like have specific engineering metrics that you can embrace, not just like some high-level, holistic, thought about like the context of the video that you care about, right? So the last few slides that I have was actually talking about a real-world practice of how this plug into our partnership with the team at Voxel. So we actually partnering with you guys over 3 years ago, right? Building a lot of cool, like small prototype and application integration that demonstrate how we work together. One of the very simple, like the example here is like semantic search, right? For data curation, which is like the entire value. I know that Voxel perspective is very data-centric, right? Your model is only as good as your dataset iteration loop. This is a blog post that actually Dan wrote on your website that talk about the end-to-end workflow combining 51 TwelveLabs and in this case, Databricks vector search for the vector storage layer. So 51 does the visualization, curation, and failure analysis. TwelveLabs provide the multimodal embeddings and semantic retrieval, and then vector search from Databricks provide the indexing part, right? Where you let's say you want to scale that into like production level pipeline, then you can use the indexing backend for like increasing amount of video. So this example here shows that you can make semantic video retrieval inspectable, right? So you can actually see what got retrieved with the curation layer, right? See exactly what clips is being shown, what did not, and why. Here is another example of a real plugin that Dan actually built. It's a semantic video search plugin on the 51 package. And it actually, follow the 4 pillars of context engineering very, very closely. So right context, you actually generate embeddings in TwelveLabs. Select context, you perform semantic search over multiple clips. You isolate context by keeping only the most important results in metadata in a organized dataset view in 51. And not shown in the example, but like you can actually compress context by providing the labeling, right? The labeling of the clips. Annotation, basically, you use our model to like provide tags and metadata from that clip itself. So, one of the things that we've been thinking a lot about is how can we sell into like data labeling company, right? This huge market these days, right? A lot of labs, a lot of annotation company, human in the loop that curate data, selling into frontier models. Using a solution like this, instead of doing human labeling from scratch, you can actually navigate the video volume more easily with semantic, knowledge, right? One of the examples that my team recently built is this worker safety prototype dataset, and actually the GitHub repo is also open source, and I can share that with the audience after this meetup if people are interested in. Quick pipeline, you got some dataset from Hugging Face, right? Get embeddings from Marengo, perform some clustering with k-means, do some visualization with UMap, and then export that into PyTorch. UMap is actually on 51, by the way, so you can actually see the cluster, embeddings clustering in their platform. So now you actually curate your own training data by semantic curation, right? And it's a great example of applying context engineering for dataset building. Okay. So I want to close my presentation with this diagram. Essentially, it talks about kind of model size and performance and accuracy. As a startup, obviously, it's hard for us to like compete with frontier models lab who have a lot more compute and data and always train bigger model with infinite resources, right? So what kind of startup building foundation models do, right, to compete with the like of like Anthropic, OpenAI, Gemini, Meta, NVIDIA of the world, Amazon Nova, of course, as well. We want to focus on context, right? Context engineering, context quality. So we like want to design our system in a way that when we train the model, it focuses more on things that matters, right? Evidence graph accuracy, provide less hallucination, lower cost and latency. So instead of like the model seeing every single possible things in a long video, you only care about the thing that matters, that move metrics for our customer. So yeah, if you want one final takeaway from this talk, it's basically about treating context like a product surface with versioning and evaluation, not just like a prompt engineering approach. Yeah. It's our website, TwelveLabs.io, if you're interested in trying it out. Our Marengo model and Pegasus model for embeddings and video analysis. And yeah, thanks everyone. Thanks again, Boxo, for hosting.